Hi everyone. We're going to do two examples of finding inverses of rational one-to-one functions. And we're going to state the domain of f, the function, and find its range using f inverse, meaning f inverse like that. F inverse. Okay. We also have to check our answer. That means composition of functions, which is probably the hardest part here. So the first thing we're going to do is state the domain of f. So we have to state the domain of f. So just by looking at it, we know that it's all numbers, all real numbers, but or such that x cannot be -2. So it can be everything but -2. Okay? And to find inverses, you should already know typically how to find them. The rationals are a little harder. So I'm just going to write this in terms of y, y here, and switch the x and the y. You know, inverses are just where you switch the x and the y and then solve for y. So I'm going to switch this here, and everywhere there's an x, I'm going to put a y, and everywhere there's a y, I put an x. Okay? Next step, so we just interchanged x with y. Next step is to solve for y. So I'm just going to cross multiply here. We get x times y plus 2 equals 3y minus 4. Clean this up a little. All right. And then I've got to solve for y. So this represents some problems for students. So basically just group your y's together. So I'm going to move him over to the right side and subtract, and I'm going to add the 4 to the left. And when you do that, you get 2x plus 4 equals 3y minus xy. And the next step is very easy. On the right side, just factor out a y. And keep the left side the same, and then just divide both sides by 3 minus x. And when you do that, you have your inverse. So basically our inverse function is 2x plus 4 over 3 minus x. Now we're supposed to check the answer, but since we're on this page here, we're going to state the domain of this. If you look at this, the domain of this is all real numbers. However, x cannot be 3, because if it was 3, then you'd get 0 in the denominator. Well, since we switched the x and y, that means that's the range of my original function. So my range, so this is for your f inverse, and so my range, let me put this in red, my range for just f is what the domain is of f inverse. So basically, it's all real numbers, but y cannot be 3. So basically, we did our domain and range, and that's pretty simple. Now all we have to do is to check the answer, which is some algebra. So basically, we're going to compose f with f inverse, and we're going to compose f inverse with f, and this all should equal x. If it does, because remember, inverses reflect over the y equals x. So if this works, then we got the right inverse. So the first thing I'm going to do is this side here, f composed with f inverse of x. Now, this is supposed to equal x, and all I'm going to do is write down my f function, which is 3x. So my f is 3x minus 4 over x plus 2. And then everywhere there's an x, I'm going to input f inverse. I should have left more room and leave more room here. And I'm going to put f inverse. Well, our f inverse was 2x plus 4 over 3 minus x. Do it in both places. 2x plus 4 over 3 minus x. Now this is where the problem comes in, and all we're going to do is a little trick and multiply this by the denominator here. So we're going to multiply my numerator and my denominator by 3 minus x. As long as I do it to both the numerator and the denominator, then I'm not changing it, I'm just helping solve this. So I'm going to distribute here. When I distribute for the numerator to the first piece, the 3 minus x cancels out. So I'm just going to get 3 times 2x plus 4. When I distribute to the second piece here, that's going to be minus 4 times 3 minus x. But what we did is we cleared the fraction in the numerator. We got rid of this because this cancels. Okay, the same thing's going to happen in the denominator. This is going to cancel here, so we just get 2x plus 4 plus 2, and you distribute here, you get 3 minus x. In this case, this part canceled, but here we have to multiply. Now, when I simplify, I'm going to get, I don't think I can get it down here. So we're going to get 6x plus 12 minus 12 plus 4x. And in the denominator, we're going to get 2x plus 4 plus 6x, no, just 6, sorry, 6 minus 2x. Well, what happens is this cancels, the 2x canceled, and we get 10x over x, and that equals x. No, 10x over 10, sorry, and that equals x. So that worked. And now we do the same for the next part. We have to go the opposite way, and I'm going to try to write it a little smaller. I'm sorry, but I'm going to try to squeeze it in here. So I'm going to try to squeeze it in this area. So basically, we write down our inverse, which is 2x plus 4. But everywhere there's an x, I put parentheses, and then plus 4, and then 3 minus my x. And my function, I'm inputting f, this is f inverse here, which is 3x minus 4 over x plus 2, 3x minus 4 over x plus 2. And we're going to do the same trick. We're going to just multiply the numerator and the denominator by x plus 2. And then distribute this and multiply by each part. The first part is going to cancel here. So you just get 2 times 3x minus 4. And then you have to distribute, you have to multiply 4 times x plus 2. And for the denominator, we're going to get 3 times x plus 2 minus, don't forget your parentheses, 3x minus 4. This cancels here. All right. Now, when you clean all this up, you're going to get 10x over 10 again. You can do that. I'm running out of room. And that equals x. Okay? And I thought we'd do one more. We'll go a little faster. So the next one is f of x equals 2x minus 3 over x plus 4. I'm going to write this with y instead. 2x minus 3 over x plus 4. Switch the x and y. You switch the x and y, you're going to get x equals 2y minus 3 over y plus 4. You solve for y, so we're going to cross multiply, and you're going to get xy plus 4x. I just multiplied these two together. I distributed, equals 2y minus 3. I'm going to add 3 to both sides and subtract the xy from both sides. Factor out the y, and then divide by 2 minus x. So y equals 4x plus 3 over 2 minus x. So you see this is very similar. This is your inverse. Let's talk about the domain. Domain of f is all real numbers, but x cannot be negative 4. And to get the range of f, so we want the range of f, we look at the domain of f inverse. Well, the domain of f inverse is all real numbers, but x cannot be 2. So I'm just going to let that be my range, so at y cannot be 2. Okay? So that part's pretty simple. The next part is we have to compose f with f inverse and f inverse with f. So we're going to compose f with f inverse of x, and that should equal x. And we're going to compose f with f inverse with f, and that should equal x. Remember, for inverses, you have to do both ways, because sometimes one way will work and not the others. If you did your math right, this should work. So the first thing I'm going to do on this one is just write down f, but everywhere there's an x, hopefully you wrote these down. Everywhere there's an x, I'm going to put parentheses and dump in my inverse. My inverse for this one was, let's see, what was my inverse? 4x plus 3 over 2 minus x. So 4x minus 3 over 2 minus x. 4x minus 3 over 2 minus x. Now to clear the fractions, I'm going to multiply by 2 minus x for 2 minus x and distribute to both pieces. The first part's just going to cancel out, so you get 2 times 4x minus 3, and you have to multiply the 2 minus x times the negative 3 here. 2 minus x. Whoops. That's the numerator. So this part canceled, but you still have to multiply it by that. Here, this part's going to cancel as well. So you just get 4x minus 3 plus 4 times 2 minus x. You clean this up, you're going to get 8x plus 6 minus 6 plus 3x over 4x plus 3 plus 8 minus 4x. This cancels, so we get 11x over 11, which equals x, which is what we wanted. Okay, now to do this side, do the same thing. Write down f inverse, which we have right here. But everywhere there's an x, I'm going to dump in my inverse. So my inverse is, or not my inverse, my original function, which is 2x minus 3. Didn't make enough room. Over x plus 4. 2x minus 3 over x plus 4. Now I'm going to multiply the numerator by x plus 4 to clear the fractions. X in both the numerator and the denominator. and distribute it to both pieces here. So the first piece, it just cancels, and you get 4 times 2x minus 3 times x plus 4 for the numerator. The denominator, you get 2 times x plus 4 minus 2x minus 3, because this part would just cancel, just like that part canceled. All right, and when you clean this up, you're going to get 8x minus 12 plus 3x plus 12 over 2x plus 8 minus 2x plus 3. Now these cancel, and you get the same thing. 11x over 11 equals x. Okay? So if you can do that, those are one of the hardest ones to find inverses for. Thank you and have a nice day. Bye-bye.